Now, for the naming of the alkanoic acid, the alkanoic acid contains COOH group, the C double bond O and then OH, or in short, we can write it as COOH. So the common one is the ethanoic acid that's present in the vinegar. Well, it's just like modified sum from the ethane CH3 and then CH3. That is changing some words and then it will become ethanoic acid. So let's see how can we change those names. Naming for the alkanoic acid. First of all, the alkanoic acid, they have general formula of CnH2n plus 1 and then COOH. And then those N will be maybe starting with 0. Or we can just simply write out COOH. The R is the alkyl group or the hydrogen. That means no carbon on the left-hand side. It is still HCOOH, for example. HCOOH is still an alkanoic acid. The functional group name is the carboxyl group. Carboxyl group, we can write it as COOH. And then what we need to do is to find the longest continuous carbon chain containing this carboxyl group. And then we're omitting the word, changing the last word, E, to becomes oic acid as the parent for the alkane. So that means if we know we don't have any alkyl group here, we just have the H here. HCOH is the first one in the homologous series, first member. That is methanoic acid. We omit the E and then we change it to METHANOIC directly, omitting the E after the ANE. So it is methanoic acid. Second one is ethanoic acid that we have shown, while the third one, it should be the propanoic acid. So 3 carbons there. And then we don't need to write the 1 in front of oic acid, just because the oic acid that present must be at the first carbon. We should label it as the first carbon. So that's why it is butanoic acid and so on and so forth. As we labeled the first carbon as the butanoic acid, first carbon for the alkanoic acid, so then the methyl group will be on the second carbon. So the name of it will be methyl propanoic acid. Now, because the CH3 must be present on the second carbon, it cannot present in the first carbon or the third carbon. Otherwise, if it's present in the third carbon, then the methyl group no longer as a substituent. It is the carbon chain already, longest carbon chain already. As a result, this one will be methyl propanoic acid. While the lower one, we need to label the methyl groups is attached onto the second carbon, because some of the time the methyl group can be stay longer away from the COOH. So it may be at the third carbon. That is the carbon that I'm pointing here. As a result, this is 2-methyl butanoic acid. While naming alkanoic acid with carboxyl groups. So to name the alkanoic acid, which contains 2 carboxyl group, this will be dioic acid. Once again, may I draw attention that is no longer alkanoic acid instead, because the general formula has already been changed. So for this one, we will say that this is the hexane dioic acid. The word E will be retained now, just like the one that we have in the parent alkanes. So it should be retained, and then it is dioic acid. So one more point is hexane dioic acid, but not the hexane 1,6-dioic acid. Just because both acid groups must be present at the first and the last carbon. So we don't need to label it as 1,6. So it must be at the beginning and at the end of the carbon chain. So we don't need to label the position for the dioic acid. If there is more than one functional group, OH, COOH, X, R, or C double bond C, that is here. The R, that is the alkyl group, or the X, the halo group. Alkyl group, halo group must be present as the prefix. While the carbon-carbon double bond will be named as En in the root, that is the stem, in the stem. While OL is for the alkano, or oic acid will be alkanoic acid in the root as suffix. That means we put Al or ace, that is the alkyl or halo, in front of the root. And then in the root, we need to consider whether the CC double bond present or not. And then in the root at the suffix part, we need to consider whether the OH group, that will be OL, or the COOH group, that will be the oleic acid, present or not. So these are the hydrocarbon chains. Just in case if you are interested, they are the number of atoms for the carbon chains. Until 100, you can assign it. So have a short summary. Like for the prefix stem and then suffix. Now here we see that stem and suffix will be the roots. So that is the prefix is about the substituents. That is the alkyl or the halogen groups. While the parent is involved how many carbons inside. And then the suffix, do we have the unsaturation or the principal functional groups present? So let's consider about the examples here. But the principal functional group would be the COOH, the acid group, while there should be substituents, that is the bromo, and then the CH3, the methyl group. As a result, it is 4-bromo, 3-methyl, pentanoic acid. Now, just because the principal functional group is COOH, so it will be assigned as 1, the first carbon, second carbon, and then the third carbon we will have the methyl group, and then the fourth carbon will have the bromo group. As a result, it is 4-bromo, 3-methyl. Why we label bromo first instead of methyl? Why don't we use 3-methyl 4-bromo? Just because about the alphabetical order. B is in front of M in the alphabetical order. So we need to consider about the substituent, the first alphabet for the substituents. So B is in front of M. As a result, it is 4-bromo 3-methyl pentanoic acid. For the stem, we need to consider about principal functional groups and saturations, and then the length. That is the numbering. We number the principal functional group first. That is the COOH. It must be named as 1, labeled as 1. So we number the principal functional group as smallest as possible. And then the next one, if there is no principal functional group, instead there is unsaturation, then we label the number for the unsaturation as small as possible. Like if we don't have principal functional group and it is saturated, then we need to label the prefix that it will be smallest as possible. So for the prefix, we have another system. The first substituent will be labeled as smallest as possible first. That means we need to count the smallest number. If you don't understand, you may refer to the one that we have in the alkanes or alkenes part. So the prefix in the alphabetical order, we need to put the position for the prefix. The one with a lower or the letter word in front in the alphabetical order will go first. So the next one, consider about the substituent. We need to consider the ditri or tetra as well. And then finally, we need to number. While the unsaturation, we need to have the CC double bond. That means we need to say in no or in noic acid. The principal functional group would be the final suffix, while CC double bond should be in front of the principal functional groups if CC double bond is present. So the parent hydrocarbon will contain mi-propylpentas, while for the principal functional groups or saturation or not, there will be ane. So we have methane, ethane, propane, or ene, ethene, propene, YNE, ine, propine, ethine, or butane. The YNE is CC triple bond. It is not in the DSC syllabus. So you can take a look for this one by yourself if you want to. Well, if it is diene, we need to remain the A here. That is buta 1,3-diene or penta 1,3-diene. So if it is diene, we need to keep the A. While if it is O, the principal functional group will go to O first. So we label it as smallest as possible, pentane 1O. Or if there is double bond presence, the unsaturation should be placed in front of the principal functional group, that is in, no, but no, in. So it should be in and then no. So the functional group as the principal one, that is OH, should be labeled as smallest as possible. So it would be labeled as 1, while 3 will be 3 in, 1 no. If there is 2 OH group, for example, 1, 2 diol, then the E should be kept. That means retained here. So it will be, for example, has 3 in, 1, 2 diol. The E should be kept here. And then those substituents, choral group, bromo group, dichoral, or bromochoral. First of all, we need to label bromo first and then choral, or bromo first and then methyl. So this one B or M. So we need to take care about the alphabetical orders as well. One of the word nitro, if you see NO2 on in the system, it would be nitro. However, this is not in the DSC syllabus as well. According to this one, the rules here, you may try the following one. The principal functional group is COOH, so it will be labeled as 1. As a result, first carbon, second carbon, and then the third carbon, we will have a methyl group. Third carbon will have the CC double bond as well. So the fourth carbon having the 4 bromo group. So 4 bromo, 3 methyl, pen, 3 enoic acid. Next one. So you may try to name it. Now, the longest carbon chain goes to the 4 carbons only. Involve most of the substituents, that is bromo, and then the functional group COOH. So this will be the butanoic acid. While on the second carbon, we have the FR group. And then on the third carbon, we have bromo group. So it would be 3 bromo, 2 FR butanoic acid. The next one, you may pause it and think it. The longest carbon chain will go to the 5 carbon chains. So we have 5 carbons here. As a result, it is pentane. And then pentane, we have methyl group as a substituent or bromo group as a substituent. As this is second carbon starting with the first substituent. So it is 2 bromo and then 3 methyl pentane. So you may consider about what's wrong for this one, the following one, and then I will show you the answer later. So you may pause it and think about it. Now, the answer is we don't have methane because the first carbon, methane, is not present in the world. CC double bond, that means starting with 2 carbons already. So it should be ethene for the first member. While dichloropropane, 2 dichloropropane. So we have to label both substituents, that is dichoro. That means you need to label twice, but not simply label 2. 1 choro, 3 bromo butane. It would be wrong because we need to label the 3 bromo first instead of choro. The fourth one, methyl propane, should be used, or you may say it is butane. Like if it is the free one, that is the propane, the third carbon containing the methyl group, it should be the chain itself. So that's why it is butane. Or if you really get the branched chain, it must be not on the third position. It must be on the second position. That is methyl propane. 2-chloropenfoine. Now, remember, the functional groups that's present must be as smallest as possible. So we need to label it is pen-1-ene, but 4-chloro. So the functional group will be smaller, but the prefix, the substituent would be larger, is okay. So it would be 4 chloropen 1 yin. Next one is about hexane. No. So remember, if it is only one, one hydroxyl group, it should be no E at all. So it should be hexane 1O. You have to label it clearly, whether it is first carbon having the OH group, second carbon having the OH group, or the third carbon having the OH group. So hexane 1, 2, 3, you have to state clearly. For this one, hexane 1, 3 diol. Now, the word here, it should be adding E. The alphabet E should be present before the diol. Hexane 1, 4 diene, again, missing E. Sorry, it should be hexa 1, 4 diene. Now, AN should be only single bond, but we don't have single bond anymore. We have some double bonds present. So it should be hexane, so no longer AN, because it is diene already. So it should be hexa 1, 4 diene. Pen 1 in 4. So again, the principal, the major, the most principal functional group should be the OH. As a result, we need to label as smallest as possible first for the OH group. So as a result, it is pen-4-in 2O. While the last one, octane dioic acid. Now, we don't need to label the position, but we need to label adding the alphabet E before the D. Otherwise, you cannot pronounce octane that. Cannot pronounce. So it is octane dioic acid. So that's the end of this part.